I'm so glad you're here. Welcome back to our discussion of the endocrine system. We overviewed the classes of, we did an overview of the classes of our hormones. So now we're going to talk about sort of the central, axis of the endocrine system, and this is the hypothalamus and the pituitary, the relationship between the hypothalamus and the pituitary. There are many glands, major glands of the endocrine system. There are lots of minor glands, but the major glands of the endocrine system are here, and these are the primary ones that we're going to focus on. The pineal gland and the pituitary gland are both in the brain. The thyroid, as you know from lab, is in the throat area, the thymus, the chest. Adrenal glands above the kidneys, and then the ovaries and the testes. All of this whole system is controlled by an area of the brain called the hypothalamus, and this is the connection between the brain and the body when we're talking about the endocrine system. So if you look over on the left, this image here, you can see that the whole head, the whole brain, and this little tiny section, this little tiny square, is what we're going to be focusing on. And of that little tiny square, just this little bit right here is the hypothalamus. And the hypothalamus is seriously what controls your endocrine system. All of the endocrine system, everything, information comes from the hypothalamus, that little tiny spot in your brain. So that's the hypothalamus. And then inferior to the hypothalamus is this really, really important gland called the pituitary. And the pituitary is actually two fused glands. The posterior pituitary, and I've given you some orientation here. Hopefully you remember that from lab. The posterior pituitary, so the pituitary toward the back of your head, stores and releases two neurohormones. So neurohormones are released from nervous tissue into the blood. The posterior pituitary is actually nervous tissue. The anterior pituitary, so front, secretes six hormones. So this front anterior pituitary secretes 6 different hormones. Every single hormone that comes from the anterior pituitary, every single one is a peptide hormone. All of them. Every single one. So if it comes from the anterior pituitary, that bad boy is a peptide hormone. The posterior pituitary stores and releases 2 neurohormones. As I said, it is neural tissue. The anterior pituitary secretes 6 hormones. It's epithelial in origin, and it's a true endocrine gland. So true endocrine glands originate from epithelial tissue. The posterior pituitary stores the hormones that are produced by the hypothalamus. So the posterior pituitary does not produce its own hormones. The hypothalamus produces those hormones. They're stored in the posterior pituitary and secreted from the posterior pituitary. The anterior pituitary secretes 6 hormones. It produces these hormones. Produces trophic hormones. So there's some confusion, debate, different terminology. Some people say trophic hormones, and then there's also tropic hormones. And these are 2 different things, but they're often used interchangeably. And what this means is that there are levels. So this is a hormone that causes the production of other hormones. So it stimulates the secretion of other hormones. All of these anterior pituitary hormones stimulate the secretion of other hormones. The posterior pituitary, what happens when the hypothalamus is stimulated, the posterior pituitary secretes vasopressin, also called antidiuretic hormone, and oxytocin. We will talk a lot about vasopressin when we get to urinary. And we will talk quite a bit about oxytocin when we get to the reproductive system. These both come from the hypothalamus through the posterior pituitary. The anterior pituitary, 6 hormones. These are all hormones that cause the secretion of other hormones. They are prolactin, thyrotropin, adrenocorticotropin, growth hormone, follicle stimulating hormone, and luteinizing hormone. We will talk about these now, but each of these we'll talk about in greater detail as we get to the systems in which they are particularly active. Okay, the anterior pituitary. The hypothalamus stimulates the anterior pituitary to release its hormones. And this image I really like because it shows you where each of these hormones primarily act. So prolactin here primarily acts on the breasts. Prolactin, lactation. Growth hormone, primarily on the muscles, also on the bones. TSH stimulates the thyroid. Adrenocorticotropin hormone stimulates the adrenal glands. And then the gonadotropins stimulate the gonads. So we've got ovaries and testes stimulated. And sometimes I think names are a mystery, but in these cases I actually think that they fit pretty well with what they actually do. Posterior pituitary. So once again, neurohormones are made by the hypothalamus up here. So the hypothalamus makes them. Then they're stored here in the posterior pituitary. My dog's being a jerk. I'm sorry if you can hear her. So they're stored here. And then when the posterior pituitary gets the appropriate signals, they are released into the blood. Once again, the two are oxytocin and vasopressin. Okay, so anterior pituitary hormones, what do? They control growth, metabolism, and reproduction. So kind of a little bit of everything. Lots of important stuff. And so we're going to go through these. Prolactin, what does it do? It controls milk production, lactation in the female breast, and as I said, it's in the name. It's released in part, it's stimulated in part by thyrotropin releasing hormone from the hypothalamus. So hypothalamus produces TRH, thyrotropin releasing hormone, and thyrotropin releasing hormone stimulates the release of prolactin. Growth hormone, release is stimulated by growth hormone releasing hormone. Ooh, isn't that easy? Growth hormone releasing hormone stimulates the release of growth hormone from the hypothalamus. So you'll see that in each of these cases, the hypothalamus is releasing something talking to the anterior pituitary. When it talks to the anterior pituitary, that causes the release of the hormone that the anterior pituitary produces. Growth hormone. Growth hormone, you'll also see it called somatotropin. As you would expect, it affects metabolism and growth. It stimulates hormone production in the liver. So you have growth hormone releasing hormone talks to the pituitary gland, tells the pituitary gland, hey, I need you to go talk to the liver. The liver then releases something called insulin-like growth factor. Insulin-like growth factor stimulates mitotic activity in the bones, in the muscles, and breakdown of adipose to be used as fuel. A negative feedback on this is something called ghrelin that represses appetite, and that comes from the stomach, because as you would imagine, growth, my ear is super clogged. Growth needs a lot of energy, so going back to that concept of metabolism. Okay, there are two gonadotropins, LH and FSH. FSH is follicle stimulating hormone. We will talk about this so much when we get to the reproductive system. Gonadotropin releasing hormone causes this gonadotropin to be released. So gonadotropin releasing hormone from the hypothalamus causes the release of follicle stimulating hormone. In males, it stimulates sperm production. In females, follicle development. So it does different things in the different sexes. Luteinizing hormone, also called LH, same thing, stimulated by gonadotropin releasing hormone. It controls hormones in the ovaries and testes, so steroids, and in females it stimulates ovulation. We will talk about this in detail when we get to the reproductive system. Thyroid stimulating hormone, what do you think it does? Stimulates the thyroid. And it's the way it gets released is thyroid releasing hormone. So this is kind of, I hope that this is like, oh, well, that's easy. Thyroid releasing hormone causes the release of thyroid stimulating hormone, and thyroid stimulating hormone does what? Stimulates the thyroid. Okay, thyroid stimulating hormone is also called thyrotropin, and it controls hormone synthesis and secretion in the thyroid. So the thyroid hormones that we talked about, the amines, T3 and T4, if you guys remember, these, T3 and T4, are amines. These are not catecholamines, these are the thyroid hormones. They're amino acid derived hormones, and these behave like steroids. They are not steroids, they behave like steroids. Maybe you remember that from the last lecture. Adrenocorticotropic hormone is stimulated by corticotropin releasing hormone from the hypothalamus. It stimulates the adrenal glands. That's adrenocorticotropic hormone. And then, so there we go. Controls synthesis and secretion in the adrenal cortex. So the adrenal cortex, these are your adrenal glands, and they sit on top of the kidneys in humans. The adrenal cortex is part of the adrenal glands. The adrenal glands have two different sections, the cortex and the medulla. And adrenocorticotropic hormone controls synthesis in the adrenal cortex, and that hormone is cortisol. So, based on that information, an unknown hormone is synthesized in the hypothalamus, made it in the hypothalamus. It's released from the posterior pituitary. This hormone caused the kidneys to begin absorbing more water. So, based on the information that you're given in this question, what hormone does this have to be? Stop and think about that for just a second. Okay, so hopefully you came up with vasopressin. The way you get that is it's synthesized in the hypothalamus. So it has to be a hormone that is stored rather than produced. So that would be posterior pituitary. Released from the posterior pituitary. It's not produced by the pituitaries. So it's synthesized in the hypothalamus. It's released from the posterior pituitary. It caused the kidneys to absorb more water, and so it needs to be the one that affects the urinary system, and that would be vasopressin or antidiuretic hormone. Okay, hypothalamic pituitary pathway feedback loops, we will start that next time.